Let's work on problem 1. Draw an activity on arrow or ADM network and perform forward and backward path calculation for the project data shown in the following table. We have, for this problem, we have 7 activities A to G, and each activity have a duration, assume that in days. And then we have predecessor. What is predecessor? We learned that in the previous lesson. Remember the name of the peers, and we work on the relationship. In this case, the predecessor is the activity that have to be completed before the following activity will be starting. So in this case, activity A have none predecessor, and then B follow A, C follow A, D follow B, etc. And draw in a activity on arrow network is an iterative process. Sometimes you have to draw several times. So that's what I show here in this video, how I do it. And it may not right at the first time, but you can be able to refine and rework on your diagram. So let's watch carefully on this, and you have a chance to practice in the problem 2. And then you can go back to watch the video for that problem 2 as well with the same method. So the first part, draw. First is draw AON network, and then later on, after we draw, we're happy with our network, we can perform the forward and backward path calculation. So with that one here, let's draw the diagram. And like I say, it may not be perfect at the first time, but first, the goal is always you have to maintain the correct relationship between amongst those activity in the project. That in this case we have 7 activities. So let's start with the activity A, and this is activity on arrow. So one activity for one arrow. Activity A have none predecessor, so we can go ahead to start that with here we have an arrow, a node, and then we have another node, and we have activity A. This is activity A, non predecessor, and then activity B follow A. So A have to be completed before B can start. So we can have that activity B, another node, and that is B. And then C also follow A, and of course that follow A. And you don't want to put C here because remember, not both activity have both same end and beginning node. So with that, we need to if C follow A, and that if we happen to start at the same node at activity B, then the end node have to be different from the end node of activity B. So with that, I put C, go here, and we have a node, and that called activity C. And then now we have, so C follow A, perfect, and now D follow B, D follow B. So just do it, D follow B, that is D. E follow B, so B have to be complete, it means that we have to get E, same like D, go out of the end node of B, go out the end node of B. That when we talk about the follow here, and that we have E. So D follow B, perfect, because D start from the end node of B, so it means D follow B. E start from the end node of activity B, so E follow B. And then F follow CD, F follow C and D. How can we do this? How can we do this? And this one here, F follow C and follow D. So either first have to start at the end node of C and end node of D, but as you can see, the end node of C and D as different node. So how can I work away with that? Then I can I assume that it go out of C. So that is F. And now F follows C. Perfect. But F also have to follow D. That is the predecessor. How can I do? Then I can make a dummy activity. There. Just only show relationship that and the arrow have to be go that way. So you can see go backward. F follow C. Perfect. F follow to the dummy. It's 0 resources, 0 duration. And then meet at the end node of activity D, so that F now follow C and D. And the last one, G follow E and F, follow G and F. So do the same. You have, let's assume, go here, go there, and then we can go, that is the activity G. So G already follow F, perfect, because they start at the end, G start at the end node of activity F. G also follow E. You do exactly the same as you connect the dummy. So from the end node of E, so end node of E, and then go through the beginning node of activity G, and then with that, it's good. We check G follow F, G follow E. So the first node, first diagram is not optimal. It's not optimal, and that is in this case, as you can see, we can change that as well. So how can I change to make it an optimal simplified schedule? It's too busy in this, intersection, etc. So how can we do that? And why I make that, a curve when the cross section to that based on the slide that you have it in the arrow diagram. So it crossover, you may use that way, and we will get on that for each node. It represents EI, LI, and I for calculation. So EI stand for early event time for a node I, or at the earliest time an activity leaving that node may begin, and then LI, late event time for the node I or event I, the latest time an activity entering that node can finish, So with that one, we go back here. First, before we work on the detail, we want to simplify this. As you can see, look at C, D, and F. F follows C and D. And I make a dummy from D and then to the end node of C. So F follow both of that. We can simplify that easily with this. With this one, as you can see. So I can redraw that quickly and erase and change this one. So we have that one here, and then we have that one, and we have B, and I leave that just for you to see what are changing. And then we have B, we have C, and we have D, we have E, for F, G. So I just redraw exactly the same. F, D, E, and then we have C, and we have the dummy go from end node of activity D to the end node of activity C, so that the activity F will follow both C and D. And then similarly, I have a dummy go through the end node of activity F from the end node of activity E, and then we have activity G, in that it follow both E and F. So how can I simplify? So they are the same. So as you can see, D, F, and C, how can I do? Can I draw that way? Can I erase this all together and I draw D, go here. That's in my D. So instead of draw the dummy and activity D on top of that, I can draw that D, and let's check if that okay. D follow B. Yes, D follow B. As you can see, D start at the end node of activity B. F follow CD. That's perfect. So as you can see, instead of draw that, I can erase this one and make that perfect for the first, and then I can eliminate one dummy activity, and that dummy I can call that D apostrophe, and then this one is A apostrophe, because that for the relationship that G follow E, D apostrophe because F follow D. That's why I call that D apostrophe. So in that case, I already eliminate one activity dummy is D apostrophe. Now, can I eliminate E apostrophe in this problem? It's not always you be able to do that. Not always you can be removed on the dummy activity. Sometimes it's necessary. But in this case, check if we can do that. So here, as you can see, why we need this? Can I draw the activity E from here to there instead of that? Everyone see that? That should be okay, right? So with that one, I can eliminate yes with activity, new activity E there, so that I can erase that. So bottom line, as you can see now from that trap, from trap here, this is trap, and then you can get the revise and refine final diagram with some changes in there. And when with that diagram, you can be able to continue for the next part of this video. Problem 1, we can perform forward and backward path calculations.